Hello. So, we will continue our discussion on cloud computing. Today, we will do some problem or some exercise on cloud economy, right. So, that whether it is economical to use cloud or when it is economical to use cloud. We have already discussed this particular topic in our previous lecture on cloud economics, and but we will see that we will look at some of the problems, some toy problem, so that it makes our concept little more clear, right. So, I just have couple of slide recap of our the earlier slides, so that it will be easy for us to get tuned to the problem, right. So, as we have discussed in cloud property, if you from the economic point of view, it is a common infrastructure like pooled standardized resource with benefits generated by statistical multiplexing, right. So, we are multiplexing the demand, so that is from a pooled resources we can do location independent, online connectivity, that is broad network access, utility pricing like uses sensitive or pay per use or pay as you go model, which benefits applying environments with variable demand levels and so on and so forth, and on demand resources. So, it is a scalable elastic resources provision deprovisions without delay or cost in the associated with change. So, overall it looks like that it is a win-win situation, that whatever we do with is all positive things, but whether it is a company or a organization needs to look into that, whether it is beneficial for its for to deploy cloud depending on its type of things. As we discussed, suppose you require system some high end system for a short period of time, then it may be beneficial to go for cloud. But suppose the requirement of the system is longer period of time, daily you are using 12 hours or so, or maybe more than that, and then it may not be always economical to go for cloud type of things. So, in economic point of view, that we will try to look at. We have also seen these slides where we try to look at that overall costing model, where cloud cost is like here the variables were there, that dt demand, dt is a demand is function of time within a time period 0 to t, p is the max of dt, that is the peak demand, a is the average demand, b is the baseline, that is the unit cost for owning the things, c is the cloud units cost, the total cost is the denoted by ct, total business bt. So, u or c by b is the utility premium, right. Like the example we have shown in our earlier slide is utility premium is 4.55. So, that means it is all beneficial to use cloud. So, what is the utility? Similarly, so we can calculate, we have shown that we can calculate that 0 to t u b dt as a multiplication of these units. Similarly, bt, that is the total baseline cost, is p into b into t, because the baseline should be handle peak time, right. So, peak demand rather. So, baseline whenever we do a baseline baseline costing or baseline decision, or whenever we own something, then we usually look for a peak demand. Like suppose I want to make system for our say MTech lab. So, what we have to say that if the number of students which can be admitted say n, so number of system we think it should be at least 10, if not more, to have some redundancy into the things. If there is a failure, then recovery means we can replace the systems, right. But in actual things, that the number of student strength may not we for a particular year of admission, you may not attend that thing, right. Usually it may be less than that, and so you have redundant resources which are underutilized or not utilized. So, when cloud is cheaper, if this cost of CT is less than BT, or utility is P by A is less than P by A, or here if we have the cost of cloud by this, what should be the utility premium, right. When the utility premium is less than the ratio of the peak demand to the average demand, then we can say it is cheaper. Now, utility pricing in the real world is not that simple. There are a lot of other things, like in practice demands often highly spikes are there, like there are maybe news stories or marketing promotion and so on and so forth. Often hybrid model is based. You own a car for daily use, where you for whenever you are going out or traveling or for a longer distance, you use those rented things. Similarly, you have your own system, but whenever you require some when you are thinking there is some peak demand, you go for those type of things. So, key factor is again the ratio to peak to average demand, right. So, that is the key factor, but we should also consider other costs which are not considered here, like network cost, interoperability overhead. If two data are talking to each other, then interoperability overhead, right. Then consider reliability, accessibility and so on and so forth, right. So, those are other things which need to be accounted for when we calculate these costs. So, we also have seen this slide again, there is a on demand services, value of on demand services. When owning your own resource, you pay a penalty whenever your resource do not match with the instantaneous demand, right. Either you penalty for unused resource or suffer for penalty for missing the service delivery, right. It can be there. So, if dt is the instantaneous demand and RT is the instantaneous resource, then the penalty cost is dt minus RT integral of that, right, like dt minus RT mod integral of that over the time period 0 to capital T. So, that is the thing. If demand is flat, penalty is 0. If the demand is linear, periodic provisioning is accepted. So, if the demand is linear, periodic provisioning is accepted. But most of the case, there is a lag between when the demand rises and the provisioning is done, right. And this sometimes may create a big challenge, because of that if the growth of demand is exponential, then chasing that demand with resource provisioning may be extremely difficult. Like here we have seen that if the demand is exponential, dt is some form of e to the power t, any fixed provisioning interval Tp, like it whenever you look for that extra provisioning, it will look for some provisioning interval Tp. So, according to the current demand will fall exponentially behind it, right, we have seen. So, at t equal to E of t minus Tp. So, you have a lag between that, right. So, dt minus RT, if you calculate something constant into e to the power t. So, that means the penalty is something C into k1 e to the power t, that means it also grows exponentially. Like if you see the picture, so that due to this provisioning delay, that it goes on, unserved demand grows on increasing. So, it is extremely difficult to chase this sort of situations, right. So, these are all practical considerations. So, it is not that just doing a simple calculation, but there are different other considerations. For that you need to have a predictive model, that whether you can say that this time the demand will increase. Like these are true for our other commercial things also. We do predict that during some seasonal things whether the demand will increase on that time and have store accordingly. Here also we need to have some predictive model to do that if at all required, right. Now, we will try to look at one or two problems which will allow us to have little more clarity on the whole thing. So, these are very toy problems, simple problem, but it by doing so it will give us some sort of a clarity or confidence into the things. So, what it says, consider a peak computing demand of an organization is 120 units, right, some 120 units. The demand is a function of time that can be expressed at this dt equal to 50 sine of t from t is 0 to pi by 2, whereas 20 sine of t where pi by 2 to pi. This is the some functional model is given. The resource provisioning by cloud to satisfy current demand t is RT equal to dt del of capital del of ddt of by dt, right. So, this is the resource provisioning, where del is a delay in provisioning the extra computing resource in time, right. This we consider. Now, the cost of provision unit cloud resource of for unit time is 0.9 units, right. So, we need to calculate the penalty. So, our assumption is that the delay in provisioning is pi by 12 time units and minimum demand is 0, there is no demand is the minimum case. Penalty either pay for the unused resource or you miss some service delivery, right. So, this is the consideration. So, we need to calculate the penalty. So, let us just have a very straightforward working and see that how things works. So, if I have your r of 0 to pi integral 0 to pi from that given equation we can do. Right. So, if we look at this portion, so it is del of dt. $30. So, on other sides this we can have so if you go on calculating, so it is 50 minus cos of t 0 to pi by 2 plus 20 minus cos of t pi by 2 by pi. So, if you go calculate, so it will come as 70, right. So, that what we have finally if you look at, so r equal to 70 plus 30 pi by 12 and your d value is 70. So, r minus d mod is 30 pi by 12 equal to 7.86. So, this is the value what we answer will get. So, if you actually this corresponds as we if you remember, as we are talking about penalty equal to is proportional to 0 to pi demand minus mod of bt. So, we get this as the value of the penalty, because in this case what we say, that is the your resource availability that provisioned is greater than your the demand. So, we get a positive value, right. So, this is again from the equation we calculate. Again I should say, this all this calculation part we have not considered the other factors like network provisioning or other type of maintenance cost and all those things, right. We consider those are those we have not considered, right. So, rather if we look at another problem, like consider the peak computing demand of an organization is 100 units, right. The demand is a function that can be expressed as Ct equal to 0 to t u into b into dt this and like this. So, this is the function what we have discussed. So, what we say the cost of cloud Ct equal to 0 to t u cross b into this we have the already seen, right. So, rather here the this is the total cloud cost, this we have already seen. Actually, if you please note the demand function, which is there is it is not mentioned here, there is some typo. So, demand expressed as a time can be expressed as 5 this 50 into 1 plus e to the power minus t. Okay. So, let me reframe the question again. Consider a peak computing demand of an organization is 100 units. Okay. So, the demand as a function of time can be expressed as this. So, if I say the demand dt is expressed as this. So, this is not there in the question because there is some missing terms. So, demand you considered 1 plus e to the power minus t. So, it is a demand is a function of time. Now, what we additionally give, baseline unit cost is 120. So, baseline, that means own unit cost is 120, right, and cloud unit cost $200, right. So, what we need to do in this situation, is cloud cheaper than owning for a period of 100 unit times, right. So, we want to calculate if the cloud is cheaper than owning it into 100 period of time. So, what you need to add here, this we need to calculate that whether if 100 unit time, if it is the utilization is there. So, it is again straightforward. So, if I see total baseline cost B t equal to P into B into T equal to 100 into 120 into this much, right. Total cloud cost C of t equal to 0 to 100 C d of t dt equal to integral of 0 to 100 to 0 0 50 1 minus 1 plus minus this into dt. So, if you do a integration, So, if you do it, it approximately comes as 10,000 so much, right, if you just do that calculation. So, what we get here, what we get 1 2 0 1 2 3 4 5 1 2 3 4 5 fine. So, what we do, utility right. So, utility premium as from our this, so 0.84 or utility premium u, what we get is u is less than 1. So, that means at least in this case cloud will be cheaper, right. I can have simple calculation to find out that what are the different for different scenarios, what are the different cases are there, right. Let us look at another problem, right. Here what says a company X needs to support a spike in demand when it becomes popular, followed by potentially a reduction once some of the visitors turns away. That means, when there can be spike and fall in the demand, right, this sort of scenarios, right. The company has two options to satisfy the requirement which are given in the table. So, what it says, purchase cost of in-house is something, and cloud server there is no purchase cost. Number of CPU cores for in-house server is 12, whereas the cloud server is 8. Cost per hour over 3 years span for the cloud server, as you are renting, it is something 42 units per hour cost. Efficiency of the in-house server, because it is underutilized, so it is 40%, whereas the cloud server is 80% when you, because you are using it when the demand is there. Power and cooling requirement in case of in-house server is 22, whereas for the cloud server it is nil, and management cost per hour is 6 in case of in-house server, and cloud server it is 1. So, again let me just repeat, purchase cost is 6 lakh for in-house and nil for cloud. Number of CPU core in in-house is 12, cloud 8. Cost per hour in a 3-year span, the rent or other type of means for cloud is 42 units, whereas for in-house there is no cost hour, you are upfront purchase the thing. Efficiency is 40%, because most of the things are there is 60 not that utilized, and whereas cloud server it is 80%. Power and cooling is 22 and nil, and management cost per hour in case of a cloud is much more, that is 6 and it is 1. So, what we need to calculate with this data? Calculate the price of a core hour on in-house and cloud server. So, that is straightforward. So, what we have, cost per hour for in-house server considering 3 years is divided by 3 cross 365 cross 24. So, if you calculate, it comes around 22.83 INR if it is Indian currency or units of cost, right. Now, if we have a cost hour for in-house, server, this is 22.83 by 12, right, because the first question was core hour for in-house server. So, core hour for in-house server is this one, is 1.90 unit, or if we consider in your thing. So, core hour for cloud server is 42 by 8, it directly comes from the question, 9.25 INR, right. Now, the question B, find the cost per effective hour for both the option. So, cost per effective hour for house is 22.83, and as it is 40% efficient, so 40 by 100, right. So, it is 57.075. So, it is INR or something, whatever the unit. Effective hour for cloud equal to, it is 80% efficiency. So, 5, right. So, this is the effective. Now, calculate the ratio of total cost per effective hour for in-house to cloud deployment, right. So, we need to calculate the ratio of total cost per effective hour for in-house and cloud deployment. So, total cost per effective hour in-house is 57.075 if we have calculated earlier, that is for the in-house servers, plus 22 because there is a power and cooling, plus 6 for maintenance management cost, and then we have 85.075. Same thing for cloud equal to 52.5, and it has only one management. So, it is 53.5, and if it is INR, fine, or whatever the unit, right. So, ratio of effective hour of in-house by cloud equal to 85.075 by 53.5, so 1.59. And finally, if the efficiency of in-house server is increased to 70%, which deployment will become better in the total cost effective hour, right. So, it has efficiency is 27 initially now 40, if we increase to 70%, so which will be better, right. So, modified, so efficiency, modified, not efficiency, modified cost plus effective hour for in-house will be 22.83 by 70% now 100. So, we get 32.61. So, total cost plus effective hour for in-house, everything is for in-house, total cost per effective hour, still it is for in-house, still it is 32.61 plus 22 plus 6, right, equal to 60.61, right. But if we see that the cloud it is still 53.25, right. Now, if it is instead of this is 70% increase, if it is a 90% in house, then if you do the same calculation, will effectively what we will get instead of this value. So, 22.83 by 90 by 100, right, it is 25.37, right. So, this total cost for 90% will become 25.37 plus 22 plus 6 53.37, right, INR. So, this is for if it is 90%, right. So, if you see 90%, then it is better than this cloud. So, it is you see, if you look at the problem. So, if your efficiency is less, right. So, your as we discussed, the overall utilization of the resource of the in-house is highly underutilized. So, you lose on those things, right. So, effectively we get a less means we get a more benefit if we take from cloud. However, if your efficiency increases, or in other sense that your infrastructure or your in-house infrastructure is, if it is heavily utilized, like as we have seen up to 90%, then it may be better than it will be performance wise better than cloud, right. This is a very synthetic toy example to show that if the efficiency if your more utilization are there, then in this cases the in-house will be better than cloud type or cloud purchasing a cloud. So, it all depends on overall what is your demand, what sort of demand is there, how long duration things are there. So, you need to take a call that whether you go for a cloud type of economically beneficial to go to cloud service provider or have in-house infrastructure. So, these three small problems on economic model of cloud shows that how by simple calculation we can find out, and though in actual practice these are more complex with considering other parameters as we have discussed. So, hope this will help you in clearing or having a better understanding of this economy behind this cloud. Okay. Thank you.